Now we go on to study the next topic, that is the family of planes. So this is very much analogous to family of lines that you must have studied in coordinate geometry, right? So by family of planes, what we mean is something like this. Right? Suppose let's consider that there are two intersecting planes. So this is the first plane and this is another plane in general. Right, so we have these two planes. Now we can clearly see that they intersect in a line. Okay, so this is their intersection. Now if you just focus on that yellow colored intersection line and ask the question, through this line in general how many planes pass? So we know that clearly there will be infinitely many planes that would be passing through this particular line. So one of them is like this, another plane would be like this, and so on. So like you can rotate it and you'll see countless planes are possible. So the set of all these planes, this is what is called as the family of planes. Okay, so we will be given two fixed planes. So let us call them as say P1 and P2, okay, which will intersect in a line, and through that line all the infinitely many planes which pass, they all form what is called as the family of the planes. Now the question is how to develop a generalized equation of any member of this particular family. Right? So for that, let us consider that for first plane we have the equation given by r bar dot n1 bar is equal to p1. You must be remembering that we had studied the very first form, that is a normal form. So this is just a small modification of that normal form. And the second plane be r bar dot n2 bar is equal to p2. Right? So therefore on this we can write it as r bar dot n1 bar minus p1 is equal to 0. Remember that p1 and p2 are the scalars. Okay, so there is no bar over there. And similarly for the second one we have r bar dot n2 bar minus p2 is equal to 0. Right? Now keeping the same analogy with the line, suppose we call this first left hand side as say u and the second left hand side as v. Okay, then the family of planes is given by u plus lambda v equal to 0. Right, so that gives us r bar dot n1 bar minus p1, okay, this is the first expression, plus lambda times the second part, that is r bar dot n2 bar minus p2 is equal to 0. Okay. So if we collect the terms which are in vector form, so therefore we can write r bar dot n1 bar plus lambda times r bar dot n2 bar. Okay, now let us take the scalar terms on the right side. So they will give us p1 plus lambda p2, right? And the end, let us take r bar common. So we will have r bar dot, we have n1 bar plus lambda times n2 bar, using the rules, simple rules of handling scalar product, is equal to, we have p1 plus lambda times p2. Okay. So this is the vector form of equation of the any general member of this whole family of planes. So lambda is called as the parameter, which is having the same role as we have the family of lines. So if we give a specific value of lambda, we will get a specific plane. If we give another value, then we will get another plane in the same family. Alright, so this is the vector form. If you want to develop the Cartesian form of the family of the planes, that is even simpler and that is better to remember. So let us see how to derive the Cartesian form. For that, let us consider the Cartesian equations of the two planes. Right? Let the first plane be denoted as a1x plus b1y plus c1z plus d1 equal to 0 in its most simplified form. And similarly the second plane be a2x plus b2y plus c2z plus d2 equal to 0. Okay. So here this left hand side becomes our u and the second left hand side becomes our v. So therefore u plus lambda v is equal to 0, right? That basic format remains the same for the family of lines. So therefore on substitution we get a1x plus b1y plus c1z plus d1 plus lambda times a2x plus b2y plus c2z plus d2 equal to 0. That's it. It's as simple as that. So of course we have to expand this, collect all the like terms x, y, z and then simplify. That will give us the final Cartesian equation of any general member of the family of the planes. So to fix a specific plane out of these countless planes, we would be given an additional condition. Say for example, no doubt that we get a general equation in terms of lambda. Suppose we are given that additionally that member of the plane passes through some fixed given point. So if we are given that, then the coordinates of the point can be substituted in this equation and we can obtain the value of lambda, which is a kind of identifier for that particular plane. So we put that lambda again back in the same equation and we'll get the equation of the plane, right? So let us practice this with the help of one example. Find equation of the plane passing through intersection of two planes whose equations are given, and also through the point 1, 0 and 2. Okay, so here clearly we can see that from the wording of the question it deals with the family of planes. So u plus lambda v equal to 0 gives us, u stands for the expression for the first plane, that is x plus y plus z minus 8, plus lambda times v means the left hand side of the second plane, that is 2x plus 3y plus 4z minus 3 equal to 0. Okay, so on simplifying and collecting the like terms, coefficient of x would be 1 and 2 lambda, correct? So therefore we have 1 plus 2 lambda times x plus 1 plus 3 lambda times y plus 1 plus 4 lambda times z. Then you have minus 8 minus 3 lambda equal to 0 as the constant term. So this equation that we have got is the representative of any general member of the family. So to fix one specific member of the family that passes through a given point, we will substitute the coordinates of that point in this equation and get the value of lambda. So therefore we have 1 plus 2 lambda multiplied by 1, so as it is. Then since y coordinate is 0, entire second term will vanish, and z coordinate is 2, so that gives us 2 plus 4 lambda, right, minus 8 minus 3 lambda as they are is equal to 0. So therefore let us collect the lambda terms that give us 3 lambda, and let us collect the constant terms which give us minus 5. So that leads us to the value of lambda as 5 by 3. So it's a kind of unique identifier for that particular plane. Now we put back the value of lambda not in this plane or not in this equation because that is clumsy. The better would be to put it directly in the original equation itself, right? So that will be easier to calculate. So therefore we get equation of required plane which passes through the specific given point is x plus y plus z minus 8 plus 5 by 3 times second, that is 2x plus 3y plus 4z minus 3 equal to 0. Okay. Now here we multiply throughout by 3 because that's a denominator, so let's get rid of that. So we will have 3x here plus 10x, so that we can write directly. So therefore 3x plus 10x gives us 13x. Then in case of y we have 3y plus 15y, that is 18y. In case of z, we have 3z plus 20z, so therefore that is 23z. And in case of constant, we have minus 24 minus 15, so that is minus 39 equal to 0. So that's the equation of the required plane.